You may have heard of multivariate analysis before, but generally it's compared to what we do, which is univariate analysis, which is looking at only one variable at a time. Pag multivariate, of course, you can simultaneously analyze multiple measurements, okay, variables, or anything that you want to correlate for each individual or object under study. Of course, this field did not develop on its own or was not developed by a single person, but rather by the progressive developments as well in various fields such as social science, sensory psychology, and even chemometrics. So to illustrate, when we do sensory evaluation, di ba usually yung mga, even though, for example, you're using t-test, you're comparing one attribute between two samples. For example, you're comparing the sweetness of sample A versus sample B. When you're doing, let's say, analysis of variance, you're still looking at the sweetness between samples A, B, C, and D, for example. But when you're doing multivariate analysis, you can, for example, look at not just the sweetness, but the other parameters of a product as well. So it allows you to therefore to look at the overall structure and look at ano ba yung magkakapareho na nasukat natin na is the liking for sweetness, for example, and overall liking for a predominantly sweet product virtually the same. So malalaman mo yun kung gumamit ka ng multivariate. And then it allows you to summarize the study because it gives you a big picture of all the variables involved, as well as characterize commonalities between, let's say you have a very diverse group of products being compared and you want to sort of map them out. So you can use multivariate analysis for that. So in food science, you could use it to measure underlying properties in evaluating food quality. So pwede nating makita dito yung iba't ibang mga bagay and or correlationships or what's important in a food. And you could also, from a quality perspective, establish which variables determine food quality. For example, we're correlating sensory properties with physicochemical properties. And as for relating consumer evaluation and descriptive analysis and physical measurements, so you can also use this now to piece together those three different sets of data and then do some multiple comparisons. So from the name itself, multivariate analysis of variance is related to ANOVA, no? This allows you to determine the existence of significant differences when compared on more than one dependent variable. For example, such as when you're looking at peanut butter and you have acceptability for overall, for taste, for aroma, and so on. So other than looking like simultaneously doing multiple ANOVAs, and lessening the error by only providing one F statistic, it does provide you an overall picture because kapag nag-ANOVA ka, you are studying one variable independent of the other. For example, kapag ikaw ay nag-ANOVA for taste acceptability across all your different brands of peanut butter, it will not take into consideration kung ano yung acceptability scores ng overall, ng aroma, etc. And it will not use those data sets to come up to look at the variances, so to speak. So when you have a significant MANOVA F statistic, this implies that the sample differs significantly across the dependent variables. Okay, that means taking all the variables into consideration, it does find a pattern. Okay, and you can do individual ANOVAs too, aid in your interpretation, although there are cases wherein individual ANOVAs would not yield significant results, but when you look at the MANOVA, it will involve a pattern, meaning to say dun sa complexity of things when kinompare mo yung iba't ibang variables, may nahanap kang pattern or significant difference. Of course, when the MANOVA is non-significant, then that means there are no differences, taking all the dependent variables into consideration. MANOVAs are usually used to look at the overall differences in the products, okay, and not just singling out an attribute across different brands perhaps, no? So in discriminant analysis, on the other hand, the goal is to discriminate or categorize your samples rather into different groups based on the dependent variables. So for sensory, maaring yun yung for example, responses ng mga tao regarding the cake, if it's peanut butter, the different acceptances for taste, texture, and so on. Okay. And what discriminant analysis does is to group these, let's say, samples based on that, no? So similar with ANOVA and DMRT, you can have a graphical map of the mean separation. And a sample of its use is to, let's say, separate products into acceptable, quote-unquote, or unacceptable ones. Okay, the core in understanding principal component analysis is knowing what principal components are. Medyo may pagka-abstract siya, so bear with me, no? Anyway, first it's used to simplify and describe interrelationships among multiple dependent variables and among subjects. So it does this by first transforming your dependent variables into new uncorrelated dimensions, which are based on the original dependent variables, supposedly to simplify data structure and interpretation. So dito usually sa principal components, yung original dependent variables mo ay tina-transform into what we call the principal components, and each principal component has a weight factor from each of the dependent variables. The typical product is a PCA map using illustrating the various relationships. So para siyang quadrant, tapos may mga arrows emanating from the center, indicating the PCAs and the primary factor loadings, no? So maganda ito kapag meron kang sangkatutak na dependent variables and you assume or you think that there are correlations such that, for example, when you have descriptive and physicochemical information that point out to more or less the same thing, like for example, the level of touchable acidity and the sourness. Okay, pero mas marami ka pang ibang variables. So kapag ginagamit ito sa sensory descriptive analysis, what's good about it is that the principal component analysis eliminates redundancies such as yun nga, correlations between dependent variables by consolidating these into principal components. Okay, medyo mahirap but intindihin pa, but we'll look at the next few slides. Generally, the number of principal components would depend on the number of your dependent variables. However, among these, yung pinakamataas lang yung pinaka-significance in terms of predicting variances in the products yung included, no? So, this is usually measured through what we call the eigenvalue. And one way to know kung alin dun sa, halimbawa in this case, 10 principal components lang yung i-include mo to for your analysis is if they have an eigenvalue greater than 1. Okay, so in this case, even though you have 10, you will only consider the top 3 principal components. Okay. So what are some of the applications na pwedeng paggamitan nito? For example, in consumer tests, we can use it to guide us in knowing the acceptability of products, considering all the dependent variables and in comparing it with other products. In descriptive tests, it does allow to eliminate redundant terms depending on how close the arrows are. And you would have more information on how the product is described in consideration of all the dependent variables and the other product. So in this case, for example, yung axis na ito is with respect to principal component 1 and this one with respect to principal component 2. So principal component 1 accounts for about 66% of the differences in your products, and in this case principal component 2 accounts for around 15%. So the two principal components added together would account for 81% of all the differences na nakadun sa products na iyon. And you can see that, for example, principal component 1 is determined primarily by your saltiness. And on the other hand, principal component 2 primarily by your cooked. I'm not sure if this is aroma or taste, pero yun, no? Similarly for this one below, as you can see here, principal component 1, 36% lang. So, mas maliit kumpara dito. And makikita nyo rin na yung mga arrows nila are not as far up, no? Parang, or close to the axis. So, medyo mas mahirap itong ganito dahil each principal component only accounts for, well, 1/3 is of course a slightly big number na. No? Pero, compared to the first one, of course, mas konti yung variance na i-explain niya. So in this case, we have 14 sensory attributes. Therefore, in total, there are 14 principal components. But out of those 14, only 2 are considered, no? And if you look at the factor loadings, no, yung values na ito, values greater than 0.7 are shown in bold. This means, or this indicates that these values in bold are the major contributors to that principal component. So for PC1, for example, these are mostly aroma attributes and flavor attributes. On the other hand, PC2 has color, acidity, and rancidity attributes predominating it. So take note that in this set, meron ding mga factor loading sa sobrang baba like turbidity, margarine, and salty, which not surprisingly, according to the study, yun yung tatlong attributes na walang pinagkaiba, lahat ng samples walang significant difference. So obviously that means na kung saan yung mas mataas na factor loadings, doon mas may significant difference across samples, no? So as you can see in this PCA plot, we have PC1 over on this axis and PC2 over here. So yung mga mataas yung factor loading sa PC1 na positive are on this side. And then kita niyo yung mga negative nandito. So yung mga mataas naman yung positive loading sa PC2 nandito sa upper half na to. So para siyang imaginary quadrants of sorts. And then as you can see here, yung legend refers to the 5 replicates each of the 5 different samples and how those replicates fall under the different principal components. So dahil magkakalapit yung mga same shape, then ibig sabihin lang yan ay yung replicates nila ay more or less magkakalapit ng profile. But as you can see, the different shapes which represent coconut oils made from different processes. So yung triangles nandito, yung rectangles nandito. So you could just read the legends, no? Each one refers to a different manufacturing process used for making the coconut oils. Alright, as this is just an introductory topic, I'll leave out some of the nuances of the PCA. So let's now move forward to factor analysis. In some regards, it's similar to PCA because it uses algorithms to reduce the large number of variables into a smaller set of factors, similar to how PCA has its principal components. Of course, ang maganda dito is you can use those new factors to replace the original measured variables. So the major difference between PCA and factor analysis is that the factors are obtained using algorithms correlating the variables to each other versus in PCA where the statistical variances are used. So also it is common to use principal component analysis first before using factor analysis so that you would have an idea, so to speak, about the correlation of the factors based on the results of your PCA plots. On the other hand, we have cluster analysis, which groups variables or cases according to predefined measures of similarity. These are usually done through the use of mathematical tools so that you can locate and define the data groupings. So similar to the discriminant analysis we've seen before in a sense. And one thing with cluster analysis is that variables within a cluster are usually highly associated. So if you apply cluster analysis to multivariate data, you can examine relationships in the sensory context either among your variables or the individuals if say you're looking at panelists. You usually use Euclidean distance in the clustering method, which is similar to measuring distances with a ruler. So if you can visualize that at least in a 2 or 3 dimensional space, then there is some sort of similarity based on how small the distance is from each other. Or you could also use 1 minus r, or the correlation coefficient, as a common measure in cluster analysis. So some applications in sensory evaluation may be, again, to examine relationships among variables or individuals, or in identifying groups of respondents that will have different patterns of liking for a certain product. So for example, you collected demographic information, and based on those demographic information, you could probably identify how likely certain individuals of maybe a certain age range, income bracket, or geographical location would be more into your certain product, no? So anyway, we won't have a case study for this one since this is introductory, but at least you'd have an idea about the tools that you can use whenever you have a set of data that's open for multivariate techniques. So multiple regression, on the other hand, deals with if you can imagine your, let's say, linear regression equations to correlate one dependent and one independent variable. So imagine transforming that into a multivariate approach, and that's essentially what multiple regression is. So you relate the multiple independent variables to the dependent variables, and in such a way, one of its applications then is to predict consumer responses based on data from a series of measurements. So It's like predictive modeling in a sense wherein if you have enough data, you could devise, let's say, a complex equation that if you input a certain type of consumer information, then you can get their predicted response to, let's say, a certain product with certain characteristics. Next is Proc-Eustace analysis. You'd probably remember this term from our discussion on free choice profiling. So Proc-Eustace is actually a character from Greek mythology, a bandit who attacks his victims and forces the victims into a specifically sized bed, either by cutting their limbs off or by stretching them to fit the bed. So napaka-dark ng kanyang story. Anyway, bakit ganun yung naging pangalan? Kasi this statistical technique is a sort of force fitting of different data sets. Okay? And so parang supposedly consensus configuration yung tawag nila doon. And this is done through some sort of data transformation through translation, rotation, and reflection. So hindi na natin i-dive into yon, but you'll get into the practical meaning of this one. So that sort of consensus fitting works by an iterative process to minimize the Proc-Eustace statistic S double star, which is the residual distance between individual configurations after the completion of the analysis. So ang bottom line po nito, dahil kapag tayo gumamit ng isang statistical tool na multivariate, you usually just need to know how to arrange the data and how to input them, and if the test is a fit for our objective or not, kasi computers na yung gumagawa niyan, hindi na yan something na may equation i-punch mo sa calcu, no? Well, most of the multivariate tests are like that anyway, no? Na pang computer talaga. But anyway, if you remember in free choice profiling, the data sets from each individual are not, hindi sila nakakahon sa isang type ng questionnaire, or, di ba, iba-iba yung sagot nila, yung pamamaraan nila ng pagsukat ng properties ng sample. So, ang gagawin sa Proc-Eustace analysis is i-force fit yung iba-ibang pamamaraan na yon ng pagsagot para i-standardize sila, in a sense looking for trends as well, parang what does this person mean with these responses and so on. Okay, so and the bottom line is ita-translate niya yung data to something na more or less parang forced na apples to apples comparison. So preference maps are actually sort of multivariate statistical techniques, in the sense that when you try to break down the preferences of a person, hindi naman lang yan dahil sa isang variable or katangian na meron yung food product, no? So in that regard, we can consider it as a multivariate technique, especially in trying to make sense of pref map data. Okay, so as you can see from the previous lectures, when you have a preference map, the display is a graphical display of hedonic information or liking or preference. Okay, so there's a single plot that would show the preference information for each consumer, simultaneously presented with the multidimensional space representing and containing the products evaluated. So you can use that information to analyze yung results mo. Also, the perceptual map presents a relationship among products and the individual differences in terms of the preference. So we know that, again, since this is a preference thing, medyo complicated siya, but the mapping would tell us something about ano ba yung mga katangian ng product na ito that would score it with a closer preference or lesser preference versus the others. So there are different ways to do it depending on the data, no? One is to use an external preference map. Mean to say, you have other data from external sources used to derive the preference map. So external meaning labas siya dun, let's say, sa sensory test na ginawa mo, and then ilalapat mo yung sensory test data into that preference space. On the other hand, it's possible to use the product space from the consumer acceptance data as your pref map, and it's also possible to use sensory or instrumental data, tapos dun mo ipoproject yung consumer data mo. Okay, so pwedeng nag-descriptive ka or nag-laboratory test ka, tapos i-juxtapose mo doon yung preference map galing dun sa consumers mo. So what's important to note here is that the individual responses undergo a regression process to sort of fit them into the product space that you have. And pwede nating masabi na kung yung mababa lang yung amount ng variance na explain for a certain consumer, then that consumer's behavior was not explained by the product space. No, meaning to say, hindi tumutugma yung ginawa mong product space in such a way na kaya niyang maipakita kung paano ba nagde-derive ng preference or nagkakaroon ng preference yung consumer na yun. So let's look at a sample pref map. So here you can see in the preference mapping for crispy pili nuts, the clusters of individual preferences can be seen definitely dito sa side na ito, where you have descriptors like pili nut, even, walnut, and certain descriptors for color. While on the other hand, there is a lesser clustering dito sa side na may rough, burnt, oily, etc. Okay, so medyo graphically it makes sense naman kung ano ibig sabihin itong pref map na to, even if we know very little about the study. So pref maps specifically allow analysts to examine individual consumer preference and at the same time look at patterns within a product space. In this case, you can relate consumer data, for example, with the descriptive analysis of a product like meat patties. Okay, so nakikita niyo naman kung saan siya pwedeng gamitin, but of course, we need to extract a lot of consumer data for this to happen. And kung isusuperimpose pa natin siya, ipoproject sa ibang information, we need to collect those physicochemical descriptive analysis or other information as well. Okay, response surface methodology. Although as an experimental design, this is useful for a lot of things. For sensory evaluation, meron siyang maraming uses, pero siguro one of them is, for example, nagpo-formulate ka ng product and you want to look at either the ratio of ingredients or the variables in your process. Then let's say, kung baking yan, amount ng harina, amount ng asin or leavening agent, or kung variable mo yung, let's say, baking time or baking temperature. So, in traditional experiments, you can only adjust one variable at a time. So, for example, one set of experiments may involve just having different baking temperatures. Sa isa naman, having different baking times. So, parang univariate yung dating. Ang problema doon, other than magastos siya sa dami ng experiments na gagawin mo, it will not really tell you what will be the effects if you combined certain baking temperature and baking time, no? Ano yung magiging effect nun sa tinapay kasi ang tinignan mo lang either of them. Okay? So that's where RSM comes into play by allowing the effects of two or more variables on, let's say, product acceptability and the interrelationships with other sensory attributes to be examined. Okay? So this is a regression analysis based on the experimental design, and ultimately it allows you to predict using a predictive equation ano yung mangyayari na. For example, even if you just tested, let's say, 13 different combinations of your variables, you can now predict kahit ano pang porsyento nung ingredient change mo between 10 to 20% flour by weight, or between a 5 to 10 minute difference in baking time by the second, to the specific second ng baking time. Halimbawa, pwede mo nang ma-predict doon. What if I bake this for exactly 335 seconds at a temperature of 451 degrees Fahrenheit and using 13.5% flour by weight? Then RSM can, using its predictive equation, tell you, halimbawa, kung ano yung magiging expected hedonic rating dun sa product na yon, or kung ano man ba variable ang tinitignan mo, like paano magiging texture niya. So yun, it has its limitations, but using stat and math, it can predict those things for you. So from the estimates of parameters or coefficients, pwede niyang sabihin sa'yo, alin dun sa, let's say, maraming variables mo, is it the baking time, baking temperature, or the amount of flour that affects most whatever variable or variables of interest, dependent variables you were looking at, no? So in this case, for sensory specifically, your dependent variable could be the acceptance rating. And if that is your goal, to have the highest acceptance rating, ang gagawin ngayon ng predictive modeling na ito ay ibibigay sa'yo yung equation na kayang makapagsabi anong klaseng combination ng formulation and process variables yung magbibigay sa akin ng pinaka masarap na tinapay. Okay? So you can also use the descriptive data to maybe counter check kung talaga nga bang tama yung pag-model mo, no? So separate, but you can also use the descriptive data towards that end. Okay? And usually ang output ng response surfaces, other than predictive model equations, are contour plots. Okay? Depende kung ilan yung variables mo, kasi kung greater than 3D, mas malamang sa malamang equation na lang yung matino mong makikita doon. Alright? These 3D plots tell you the peak levels of variables to achieve your optimization effect. Kumbaga, if you have an X, Y, and Z axis telling you baking time, baking temperature, and the amount of flour, then it will tell, makikita mo doon yung highest point niya kung saan itong combination na to ng tatlong yan ang ibigay sa iyo ng best amount of highest acceptance rather. Okay. So in this example, if I'm not mistaken, from Dr. Villarina's outputs from her PhD dissertation, she looked at Australian sweet lupin flour, ASL, which is a pulse, no, category of legumes, so ground into flour. Okay, and she was looking at the effects of 5 factors at the same time with respect to yung optimizing yung consumer acceptance ng resulting bread, no? Kasi ang relevance nito, of course, ASL flour has health benefits na compared sa kung wheat flour lang yung bread mo. Okay, so she's looking at for example, the type of flour based on mean particle size. So, iba-ibang fineness ng arena niya. The level of flour incorporation from 5 to 40% of the composite flour. Hindi kasi pwedeng 100% ASL flour, no, dahil medyo magiging ano na yung tinapay mo, iba na, hindi na siya yung nakasanayan mo. Amount of moisture or water incorporation per 100 grams of composite flour from 40 to 80 grams. Sponge and dough mixing time from 4 to 12 minutes, and baking time from 10 to 25 minutes. So, uh, basically, ang ginagawa dito is gagawa ka ng sets of experiments na magsasabi sa'yo using these within these ranges of minimum and maximum values for your 5 variables, anong combination ng mga yan yung magbibigay sa'yo ng pinakamataas na acceptance, and at the same time, it gives you an equation that would predict the acceptance of your bread depending on any combination of variable values from between these ranges. Amazing. Okay, so alam natin halimbawa na yung predictive equations, they have to be like variables and numbers, right? So alam natin kapag yung mga linear equations, y is equal to mx plus b, kapag quadratic equations, meron kang ax squared plus bx plus c. So dito, kada isang factor, so you have your c, your constant, then you have your linear factors, parang ito yung x, y, z, a, b mo. And then meron ka dyan ko, ito yung magiging x squared mo, y squared, and so on. Then this would be your xy, yz, and so on. Gets nyo? So lahat yan, merong kadikit na number. So kung hindi siya 0, then magiging part siya nung predictive model equation mo. So ang daming terms, di ba? Pero syempre, yung significant terms lang yung ini-include. Kasi yung iba, sobrang liit. Okay. So parang ito, as you can see here, you can translate each of these columns of numbers into an equation based on the variables and their interactions to predict the acceptability of color, appearance, flavor, texture, and overall, so on and so forth. Similarly, the bigger the number, of course, the higher the effect would be, no? So for example, if you look at color, syempre expect mo yung baking time, may effect dyan, alright? So on. Although it has malaki yung constant niya, so napapaliit nito yung overall effect. Ano ba titingnan natin? Ayan, flavor. For example, mataas yung coefficient for water, which means the amount of water would can impact the acceptability of flavor, and so on. So ito naman, meron tayong contour maps. Kung familiar kayo sa literal na contour map, yung mga mapa na nagbibigay sa iyo ng elevation kahit na 2D space lang siya, parang ganun din itong mga contour maps natin, no? So the numbers in this case represent the mean hedonic rating. We know that 6 is like slightly and 7 is like moderately. And in this case, it only shows us the values of the acceptability score based on the combinations of two variables, presuming perhaps that all other variables were held constant. Okay? So in this case, makikita natin na for example, dito sa A, this is the level of water versus the level of flour. So there's an optimal level of water and flour that would give you the highest acceptance. And depending on where you adjust between level of flour and level of water, pababa na siya from there all the way here. So pag masyadong maraming flour, masyadong maraming tubig, mababa, no? Yung score dito sa region na to. And there's that sweet spot over here that would give you the 7. So similarly for mixing time versus flour incorporation, ayun din, meron ka ring, ayun, yung sweet spot mo. More on the longer mixing time in this case kasi pababa siya, di ba? And lower flour incorporation levels, okay? And in terms of, for example, baking time versus particle size, right? We could see here na medyo, ayan, nasa gitna yung sweet spot mo. Medyo malaki naman yung tolerance niya, no? So, medyo hindi masyadong malaki yung effect nitong dalawa combined. Alright, so I guess that's it for now. For as an introduction to multivariate analysis. Medyo complex, medyo mahirap talaga siya intindihin kasi deep statistics na ito. So ang goal lang natin is malaman ninyo talaga that these types of statistical techniques exist and we can use them, pwedeng aralin on our own. And of course that we need mostly expensive statistical software to perform most of these because they cannot be done by hand. Okay? So, yun lang po and thank you very much.